Okay, period 2 statistics students, this is your class video for the week of Monday, March 23rd. So we're going to start by taking a look at your calendar. So please take out the calendar. And there are going to be a couple of changes. So it's important that you have your calendar out so you can make these changes. Because this is a work week for you, excuse me, a Friday work week for you, there will be 2 days you'll have work study assignments. And so when I made this calendar, I only had that indicated on Tuesday the 24th. So you need to make a note that on Friday, March 27th is a work day. So this that I have here will not apply. You will have a work study assignment just as you do on Tuesday. That's tomorrow. So let's go through day by day today. Obviously, you're watching the video that I posted on Google Classroom. So your assignment for today is to read, if you haven't already, or reread, would be a good idea, pages 295 and 296 in the book, in this chapter 12. There are some Khan Academy lessons, which I'll discuss here in a second. And then you have 2 videos that I posted today. The one earlier today, which was for every student, mine, and all my classes, that's really important you watch all the way through in regards to some announcements in general. And then also, obviously, you're watching this one for this specific class. And then you do not need to do the permutations versus combinations worksheet. Okay, so there are Khan Academy lessons. What are they? There are actually a number of videos. It looks like a long list, but most of those videos are only 2 minutes long, maybe 3. They're examples. It's important that you watch them all. And then there are 2 exercises that are actually assigned. Just like you had last week, you had an exercise that was assigned. You have 2 that are assigned this week. One is called the counting principle, and one is called permutations. So watch where it says exercises, and those are the ones that you need to try several times until you get at least a 70%. And obviously, as you're working through it, you have the chance to rewatch videos and take hints. So do that as you're working through those. But those are the 2, the counting principle and permutations, that are exercises. Those are the ones that I want you to complete. And you'll notice the due date on those is Sunday at 11:59 p.m., March 29th. So because you have 2 work days, we're moving those exercises to be due on Sunday night at 11:59 p.m. In addition, there will be a Google form assessment as well. So those go into your grade book as homework. The exercises from Khan Academy go in as homework for completion, as long as you get a 70% or above. And then you get full credit. And then also your Google form assessment will go in as a quiz grade, just as the one you did this past weekend will. Wednesday is office hour day. So that's from 9 to 9:45 a.m. I'll be available for this class, and then again in the afternoon. So I'll just be available if you're interested in joining those office hours. Send me an email, and I'll invite you to the Zoom. And then on Thursdays, our Zoom class day. So just like last week, we'll plan to meet from 9 to 9:45, and I'll be sending out a video this week on Zoom. We need to do a few different things this week. Last week was a trial run. We need to do a couple of different things this week. And so I'll send a note out on that as well. Your permutations worksheet is the one you need to focus on for this week, and I'll show you a couple of examples of that here at the end of this video. So the main things are, once again, Friday's a work day, so I changed this to work study assignment. And this week our focus is going to be only on permutations, and so you're looking at pages 295 and 296 in the book. All right, speaking of which, let's turn to those pages. Page 295 and 296. Okay, you've read this once already, hopefully twice. There's a lot of information in here, but the main thing to keep in mind is, what is a permutation? Okay, a permutation is another word, as it says here, for order or arrangement. How can I take a set of things and arrange them? Okay, the way we do that principally is the math tool. We use the function called a factorial. Okay, so we did discuss this briefly last week, that if we take a number and put an exclamation mark after it, an integer number, so it's a whole number, then we take that result, we find that result by multiplying, as it shows right here, multiplying that number times every integer number that is less than it until I get down to 1. Well, the 1 doesn't really do anything, right? But essentially, I'm multiplying that number times every integer number less than that number until I get down to 1. And that tells me how many different orders I can place 8 different items, okay? And one way to think about it, as you'll see in the Khan Academy video, is think about making a box, right, for each item. Okay, and when I have that first box, how many things do I have available there? Well, if I start at the beginning, the first box, I have 8 things available. Okay, once I have that box full, then the next box only has 7 items left that I can choose from, and so forth. Every time I put something else in the box, it reduces down by 1 the number of items I have available. So that's where the factorial arrangement comes in. It comes in as a product, and no matter sort of how many items I start with, the number of permutations will always be that number factorial. If you understand factorial to mean this particular product. Okay, so that's the basic idea of what a factorial is. We can ask other questions that are related to this. For example, talk about a track meet. Oftentimes we only report the first 3 places. Okay, so we might be interested in knowing, well, if we have 8 runners, how many different ways could we fill those first, second, and third places? Okay, so it's the same idea as the boxes, right? We can take just 3 boxes, and if we stop after those 3 boxes, then this is the number of different ways we could put those 8 runners in order for second, third place, 336. And the way we do that is we rephrase our question. Now we're not just interested in the permutation of those 8 things, but we're interested in the permutation of the order of those 8 things taken 3 at a time. And there's a different way that we can notate that. So at the bottom of the page, you're going to see this. And the way that we do this is by this notation, which will show up on your worksheet as well. That's on page 295. So if you turn the page over, I'd like to work out with you just a couple of problems in this do the math section. Okay, so in the do the math section, there are some problems related to factorials, and it says we want to do some practice. So I'd like to do numbers 2 and 6 on page 296 in the do the math section. So problem number 2 says 6 factorial. Okay, so if I want to evaluate 6 factorial, okay, 6 factorial is the product of 6 and all of the integer numbers that follow 6 down to 1. Okay, so this is the result, and now I can multiply these together. And just think about multiplying a set of numbers. You can do them right in any order when we multiply. That commutative property of multiplication or associative property, I can group them in any way I like. So, you know, you're going to do this differently. Maybe some of you try to do it without a calculator, because most of these you can do if you just sort of think about grouping things together that are easy to multiply together, like 5 and 4. We know that's 20. Right? And 3 times 2 is 6. We don't really need the 1, right? And then we have another 6 out here. Okay, so take 5 times 4, multiply those to get 20. 3 times 2, you get 6. I have 6 times 20 times 6. 6 times 2 is 12. And then I have an extra 0 there, so that's 120. And then I have 12 times 6, which is 72. And then I have that extra factor of 10. Just put the 0 on the end. Okay, you might do that in a different way. See if you can play around with it on your own and come up with different ways you might multiply those numbers together, and try not to use your calculator and see how well you can do. I bet you can do pretty well. Okay, and then number 6 is another problem. Okay, and this has a fraction form with some factorials in it. 10 factorial divided by 4 factorial, this means multiply. So 4 factorial times 6 factorial. Okay, so we're going to take 10 factorial divided by 4 factorial times 6 factorial. Okay, notice there's no multiplication symbol here, but when numbers are together just like that, we understand that to mean multiply. Okay, so we have 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Boy, that looks like that's going to be a huge number, and it is. But the good news is we're probably not going to have to multiply all that out. And why am I so confident? Well, look what's going to happen when I multiply out 4 times all its factors, and then I also have 6 times all, not all its factors, sorry, times all of the numbers smaller than 6. All right, so now we just have this fraction with a whole bunch of common factors in it. And what do we know about common factors in fractions? They divide out. So first thing to notice is I have this string of numbers, and in multiplication. It's the very same one down here. So just like that, all those numbers disappear. Okay, really what's happening, of course, is that we're dividing them out. And all these just turn into ones. Okay, then I have this much smaller thing left. And I'm going to do the same thing and look for common factors. And I really don't even worry about this 1 anymore. But I am going to notice that 4 times 2 is 8. And I am going to notice that 3 goes into 9 3 times. Okay, so all of a sudden, the only thing that's left is a 10, a 3, and a 7. Right here, 10 times 3 times 7. All the rest of these are canceled out. And there's absolutely nothing left in the denominator other than ones. Okay, so all these divide out, they leave ones, and now all I have is this. Okay, so that's 10 times 3 times 7. 3 times 7 is 21, times 10 is 210. Okay, so the factorial gives us this string, this product, but in expressions like this, we're not going to multiply that whole thing out, because what's going to happen is a lot of it's going to cancel out. Okay, so in this example, the answer is 210. Okay, then there's this other notation I want to go over, which is this thing. Okay, it looks like a funky little symbol. Okay, the P stands for permutation. Okay, the N stands for the number of different items I have. So in that previous example in the book, 8 track runners, for example. And R is the number of items I'm taking out of that group. So it could be as big as the same, right? If I have 8 things, I could choose 8 things. I can't choose more than 8 if I only have 8 to choose from. So R could be up from 1 all the way up to 8, okay? And the way we evaluate that is actually found on page 296. Okay, here's that formula, NPR. This means the permutations, capital P, of n objects and unique objects or different objects, 4 at a time, 5 at a time, up to however many I have at a time. Okay, and this is how it works. Okay, there's 2 factorials I evaluate. N is the number of different things I have, and then this is the difference. How many do I have in total minus how many I'm taking out of that group. Okay, so we're going to do the just checking section on the top of page 297. We're going to do these 2 problems together. Okay, so it says you just downloaded 5 new albums to your iPod. This book was written a few years ago, right? And you're eager to listen to them. How many different orders can you play them in? So what's it asking? I have 5 new albums, and I want to play them. And what are the orders? How many different orders can I play them in? So this is just simply a straightforward factorial. So I have 5 things, and I want to know how many different ways can I put them in order, and that's just 5 factorial. So that's 5 times 4 times 3 times 2 times 1. Okay, 20 times 6 times 1, that's 120. There's 120 different ways I can listen to those 5 albums in order, right? So that's how I could calculate that question. Question 6 is different, right? Now I have 8 favorite albums to be played in random order, but I can only have time to listen to 5 of them. So unlike problem 5, where I'm listening to all of those individual things in order, now out of 8 possible albums, I can only choose 5 of them to listen to. So this is going to be a permutation because we're talking about order, okay? And we have 8 items, and we're choosing 5 of them. So this is the total number of items I have. This is the how many I'm choosing to listen to. In this case, albums, 8 albums, I'm listening to 5. Okay, so we go back to our formula over here on page 296. Okay, this is my N, 8 is N, and R is 5. Okay, so I'm going to write down N factorial. Okay, so that's 8. And then inside parentheses, I have the number 8 minus 5. So that's 8 minus 5 factorial. Okay, so that's 8 factorial. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by Inside here, 8 minus 5 is 3 factorial. So that's 3 times 2 times 1. Okay, just like the example above, those cancel. That's a big number, okay? So once you get into these bigger numbers, please do use your calculators to make your job a little easier. Okay, so we're gonna have 20 times 6 times 7 times 8. You know, I probably would grab my calculator out for that one, just because it's a little bigger than I wanna be able to try to do in my head, unless I have the time to. Okay, I guess the lesson is don't choose your calculator so fast. If there are problems you can actually do without them. You'll be better off overall in life, okay? So there's 6,720 different ways that I can listen to 5 albums out of 8. It's a lot, right? It's maybe a lot more than you thought. Okay, all right, so that's the some examples for you. So watch the Khan Academy videos and do those exercises. On your worksheet, which is this one, okay, the permutations worksheet, okay, I want you to work these out, okay? First 4 problems list all the possible permutations. So what are the different orders I can put these different items in? Okay, here, look in the middle of the page, you have some examples that we just looked at. Okay, evaluate the expressions. So now the formula here on page 296 is going to be really useful for that section. Okay, and then just number 11 and 12, find the number of unique permutations of the letters in each word. So here's an example, right? If I want to find the number of permutations in the word math, okay, there are 1, 2, 3, 4 unique things that I can put in different orders. And every order is going to be a different word, okay? So the number is going to be 4 factorial, right? So that's 4 times 3 times 2 times 1. So that's 24. Okay, 24 different ways I can reorder the letters in the word math. Okay, we're not going to do these yet because what you're going to notice is that, right, we've got letters that are repeated, and there's a special way to handle that, and I don't want to do that yet. Okay, we'll do that later this week if we have time. Okay, so focus on problems 1 through 12 and have those ready for you when we come back together for our class on Thursday. Okay, send me questions. Make sure that you watch one more time. Let me just remind you. Make sure to watch the video that I posted earlier today about the week and common announcements that are true for every class. So hope you're doing well, and send me questions and comments in emails or see me at office hours as well. Okay, guys, take care.